In this part of my project, I'll show the result of the model I built to detect spam emails. After training the model, I tested it to see how well it can recognize spam messages and how accurate it really is. First, I am uploading the dataset. The dataset contains over 5,000 email messages, and each one is already transformed into numerical features. This is the data I will use to train and test the spam detection model. Now I am splitting the data into features and labels. The features are content of email, and the label tells us whether it's spam or not. This separation is needed for training the model, and without this step, the model wouldn't know what to learn or how to evaluate its predictions. To check how well the model works, I split the data into 80% for training and 20% for testing. This helps us test the model on new unseen emails, and a proper split helps avoid overfitting and gives a better picture of real performance. LSTM models need input in a 3D shape, so here I am reshaping the data. This format is required here. This format here requires the number of words, the number of emails, and one feature per word. And reshaping the input is really necessary because LSTM expects data in sequences. Here I am creating the actual LSTM model. It has 128 units in the LSTM layer, a dropout layer to reduce overfitting, and a dense layer to output 0 or 1 or spam or not. This structure helps the model remember important word patterns in each email. This part I compiled the model using binary cross-entropy, which is perfect for spam detection since it's yes and no classification. And Adam Optimizer, it helps speed up training. And using a write loss function and optimizer plays a bigger role in how fast and how well the model learns. Now I'm training the model for 5 epochs. Each epoch here means it goes through all the training data at once. You can see the accuracy and loss after every round, and the changes in accuracy and loss over time. It helps me monitor if the model is improving or not. To see how well the model was learning, I plotted training graphics. On the accuracy graphics here, I could see the accuracy going up every round, which is good, and on the last graph, the line goes down. That means the model is improving and making fewer mistakes. And both of these graphs gives a visual confirmation that the model is learning from the given data. Once the model was trained, I use it to make predictions. For each test email, the model gave a number between 0 and 1, and if it was higher than 0.5, it said that email was spam. And this threshold helps turn possibilities into actual decisions. Now we have confusion metrics. Confusion metrics here shows how many emails were classified correctly or incorrectly. There are 4 results here. We have true positives, true negatives, true positives, and false positives and false negatives. The top left here and bottom right cells are correct predictions, and the darker the blue it, the better. This matrix makes it easy to see which types of error the model is making. Next, we have classification report. This classification report gives more details. My model here, it has around 72% accuracy overall. It's very good at finding non-spam, but less confident with spam, which is normal for many models. And finally, here we have F1 score bar chart. I can say it like that. This final chart shows that F1 scores for both classes. F1 is a mix of precisions and recall, and we see that the model is more accurate with normal emails than spam, which is expected. And this also highlights the challenge of correctly identifying rare or less frequent spam messages. And in the end, the LSTM model gives very solid results and show that it's capable of detecting spam emails. Also, there is still room for improvement, but the results are very strong starting point, and with more data or advanced techniques, the accuracy can be improved even further.